In this video, we are going to learn about the future value of annuities. But before we begin our lesson, I wanted to teach you our get rich strategy because that's what I promised at the end of the previous video. So this is the first strategy that I'm going to teach you to get rich. And it's based on the idea of what we learned in the previous lesson of present value. So just to refresh your memory, the present value formula, present value is equal to future value times 1 plus I, all of 1 plus I to the power of negative n. So let's say you're 20 years old, okay? And you want to be a millionaire when you turn 55. So you have your future value, and let's say you're able to grow your money at 7% per year compounded annually. And let's say retire by 55. So that's a 35-year timeline we're looking at. So how much money do I need today to grow to $1 million if it's 7% per year compounded annually, and let's do it for 35 years. So if you look at it, it's $93,662.94. So this is our first strategy to get rich. You have a giant chunk of money. You just let it sit there for a long time, and after a long time, it's going to be an even bigger giant chunk of money. Okay? This is basically what we've been saying since the beginning of the unit. You want to ride the exponential curve. Okay? You want to ride the exponential curve, so give your money lots of love. Give it time to grow. Because if you don't give it time to grow, well, it won't grow. It'll be very sad, and you won't be able to retire very rich. If you can even have a chance to retire at all. Okay? So this is our first strategy, but unfortunately, this is probably not the strategy for you. In fact, it's not the strategy for most people. Why is that the case? Because who has $94,000 lying around when they're 20 years old? I certainly didn't. So unless you do, then you can apply this strategy, but if you don't, we have our second strategy. And that's the lesson that we're going to talk about. Future value of annuities. You know what, the best way to explain it is by looking at this pretty simple example here. So Charlie is awarded $500 per year as long as he maintains a certain average mark for each of his 5 years of high school. Charlie plans to deposit his award at the end of each school year into an account that pays 4% per year compounded annually. First of all, good job, Charlie. Did he spend the $500? No. He invests the money. Okay, so I'll do a quick side story. So there's a radio station right now. They're awarding $500 a contest. Okay, you call in and then they call back and you get $500. And every time they ask, what are you gonna do with this $500? Not a single person I hear on the radio says, I'm gonna save that $500 and invest it. Everyone's just trying to spend it. So you know what? I think that the message in the public is just we don't emphasize on playing the long-term game. So yeah, good job, Charlie, for saving it. So we have a beautiful diagram here. It's called timeline that shows you how the money is being invested. Okay, so after 1 year of high school, it gets $500, another $500. Another $500, another $500, another $500. So at the end of 5 years, how much money does Charlie have? Now, most students will say at the end of 5 years, Charlie has $2,500. But that would only be true if Charlie just stuck the money into his wallet. Okay? Once he got the $500, he stuffed it into his wallet, then sure, he has $2,500. But that's not what he did. He took the money and invested it right away. So if that's the case, he doesn't have $2,500 after 5 years. Let's take a look here. The first $500 he got from his parents, that was compounded 4 times, right? Because at the end of the first year, he can compound once, twice, 3 times, 4 times. That's 4 compounding periods, okay? Because it's compounded annually. And the second payment was compounded 3 times. The third payment was compounded 2 times. The fourth payment was compounded once. And the fifth payment was not compounded at all. So of the $500 he got from his parents, which one is worth the most? Hopefully, you can see that the first one is worth the most. The first $500 he got is worth the most because that $500 was given the most love. It was given the most amount of time to grow. So that first $500 he got is worth the most after 5 years. And the one that's worth the least is the one he just got because that was given no time to grow. So that one, yeah, based on your understanding of future value and present value, this last payment of $500 he got from his mom and dad, unfortunately, I mean, it's good, it's $500, but it was given no time to grow, so it's still worth $500. So what we're going to try to do now is try to find the sum of the future values. Okay, so we have 1, 2, 3, 4, 5 future values. Well, I guess you can argue this is just present value. But anyways, we want to find the total value or the future value of annuity. Okay, so how can we do that? So let's look at the value of each payment here. Do you see anything? Do you see a pattern here? So each one of these, I really want you to think back to the previous unit, but these are terms of a geometric series. And if they're terms of a geometric series, then guess what? You can use the geometric series formula to find the future value of annuity. Okay, so basically, your first term, A, is R, and then N is the number of payments, and your common ratio is 1 plus I. And if you sub all of this in, you can generate the formula for the future value of annuity, which is what we have here. Okay, I know it's a little big, and you can generate the formula yourself. Okay, like I would highly recommend you to do it. In fact, if you go to the textbook, I think one of the questions is to ask you to generate the future value of annuity formula. So, you know what? Let's use the formula. Kristen wants to have $4,000 by the age of 18. She makes deposits of $75 into an account that pays 6% per year, compounded monthly at the end of every month for 4 years. She just turned 14. Will she be successful? So, you know what? Let's calculate the future value here. So $75, that's your regular deposits or regular payments. Your interest rate per compounding period, that's 0.06 divided by 12, because compounded monthly. So that's at the end of every month for 4 years. So that's looking at 48 months. And then just punch that in your calculator. So there are different ways to do it, but I just follow BEDMAS. I go inside out. So perfect, $4,057.34. So Kristen is able to, was she able to reach her goal? Since FV is greater than 4,000, therefore Kristen can reach her goal. Okay, she's successful. So it's a good idea for her to put in money every single month. I know it's a small amount, but you know what? That's how you're able to get rich. So this is our second strategy. If you can't do one giant, bag of cash, you know what? Do small bags of cash, and those small bags of cash will become medium-sized bags of cash. But then a collection of medium-sized bags of cash will be a giant bag of cash at the end of the day. Okay, so I would argue the second strategy is all about discipline and patience. If you are disciplined and patient, you'll be able to get rich. You have to play the long-term game. So hopefully, you can apply this strategy. In fact, everyone can apply this strategy. And in fact, most people who become millionaires apply this strategy. They're very patient and they're very disciplined with their money. So this question, I really want you to try it for yourself. It's really, really powerful. Okay, so I'll make up some numbers and hopefully they're close to the ones that you're going to use. So you are, let's say you are, if you're 11, let's say you're 16 years old. Okay, you want to retire by the age of, please don't say something silly. I have no clue what the average retirement age is in Canada right now, but if I had to guess, I want to say 63. So I'm gonna just make a guess. The average age, I'm gonna let's say 60. Okay, you want to have This is totally up to you. Depends on how you want to live when you retire. Do you want to be eating peanut butter and jelly every single day, 3 times a day? Do you want to travel? Do you like it's all dependent on your lifestyle. So you want to have, I don't know. If it was up to me, I want like 1.5 million. I want $1.5 million. By the time I retire, I would feel very comfortable with that. And in my previous video, if I happen to die young, you know what? My wife gets the money, my kid gets the money. I couldn't be happier. How much do you want to? Okay, so this is the key point. How much do you have to invest at the end of each month? If these are the conditions, 5% per year, compounded monthly. So I'll talk about why this question is unrealistic, but at the same time, it is still helpful. So I'm going to punch into the future value annuity formula. So 5% per year, compounded monthly. Wow, there's a lot of compounding periods. So let's say just turned 16. So we're looking at 44 years times 12. That's 528 deposits or payments, right? 44 years, 12 times a year. Okay, so 0.05 divided by 12 plus 1, what was it? 528. Ooh. Okay. Ooh. So we're looking at $782 a month. Wow. $782 a month. If you think this is a very large amount, which it is, what you can do is retire later or decrease this number here, 1.5 million. Just retire with 1 million instead of 1.5. Or you can start younger. Now, why I'm saying this question is unrealistic is because you probably won't be able to start at 16 years old to do this, because how many 16-year-olds have $782.83 a month? And something else that's unrealistic is you're assuming you're gonna deposit the same amount from 16 to 60. What's much more likely to happen is in the beginning, you don't deposit as much because your job or you just don't earn as much. But later on, like when you're 30 or in your 30s or in your 40s, you're earning more and you'll be able to increase your amount of savings. Okay, so this number that you get for R should change over time. Okay, you should be able to increase your savings as you get older. But nonetheless, this is a good start in terms of your understanding of savings. So wow. Okay, so therefore invest or save up $782.83 per month. So, how much of the 1.5 million is interest? Okay, so what I'm going to do is I'm going to take all that 1.5 million. Some of that 1.5 million is interest. The question is how much? So you're going to subtract by, well, how much of that 1.5 million is your money? 528 payments of 782.83. Okay, 528 payments of 782.83. That's your money, and the remainder must be interest. Okay, so 782.83 times 528. So that's 413,000. Whoa. Which means $1,086,665.76. That is interest. Oops, I got so excited I wrote the wrong number. I'm still baffled. I'll explain why I'm baffled. Okay, so of the 1.5 million, over 1 million is interest. Let's say 1 million, okay? In fact, it's really close to 1.1, but anyways, 1 million is interest. So most of the money is not your money because you let time work for you, let your money work for you, right? You started when you're 16 and it's growing till you're 60, right? So a lot of the early deposits of $782.83, those are racking it up. You're giving them a lot of time, 44 years of growth, right? That's a lot of love you're giving your money. So yeah, that's our secret strategy number 2. Just small wins. Okay, if you did this once, if you invested $782.83 once, that's horrible. But if you do it 528 times, that's wonderful. Especially if you're able to do it when you're younger. Okay, I know it's challenging. I know it takes discipline because, you know, who doesn't want to spend that $782 every month, right? I'm sure there's a lot of things you can think of to buy, but if you choose to be disciplined, you'll reap those benefits. Okay, so for example 3, it's a little repetitive, but it's a good question. Felicia plans to invest $2,600 at 8% per year for the next 15 years, and she has a few ways to do it. She can invest it. She could just invest $2,600 at the end of the year, or she can actually break it to quarterly deposits. So $650 4 times is the same as $2,600. So what's better? Should she invest just $2,600 at the end of the year, or should she invest every 3 months, $650? So I'm tempted not to do the last 2 calculations. Okay, I'll let you figure it out. So let's do these 2, and I'll let you think. So 8%. And now if you make quarterly deposits, then the interest rate per compounding period is 0.02 instead. 4 times a year for 15 years is 60 times. You know what? I'll just do it. Weekly, monthly, so that's 12 times a year for 15 years. That's 360. Oh, sorry, 180. 52 times 15, that's 780. 52 times for 15 years, 780 times. Okay. So regardless of which strategy you choose, you're still investing a total of $2,600 a year. Obviously, there are different ways to do it. You can do it more frequently, for example. You could do it weekly, or monthly, or quarterly, as opposed to annually. So we're going to do annually and quarterly first, and you'll see which one's better. So that's 2,600, 1 plus 0.08. What is it, 650? All right, so before we do the math, I want you to ask yourself which one's going to have the greater future value. Hopefully, you already know the answer. So if you do it annually, you'll get about $70,595.50. Ooh, but if you do it quarterly, you get $74,133.50. Let me just quickly check. I feel like I did a typo here. No, that's what it is. Let's try here. No. All right, it is what it is. Okay, so is that what you expected? Which one's better? Of course, if you make quarterly deposits, you'll have $74,133.50, which is obviously greater than $70,595. But why is that the case? Well, it's because if you add your money, or if you deposit your money more frequently, you're giving the money chances to grow, right? If you wait till the very end of the year, you just wasted a lot of time. Why did I waste all that time? Why don't just, if you have the money, just shove it in and let it grow? Why are we waiting a whole year? Because that time lost, well, that's time lost in terms of growth of your money. And that's why you end up with a lesser future value if you make annual deposits as opposed to quarterly deposits. So if you can imagine, for monthly deposits, you'll have a number greater than $74,133.50. And weekly is even better. Okay, so between annual, quarterly, monthly, and weekly, weekly is the best. Okay, so I'll do a quick calculation. So if it's monthly, what are we looking at here? Okay. Yes, as expected, it's a little bit better. And a little bit better. So if possible, just automate it. And every time when you get older, when you get paid, just set aside a small portion of money, and you'll be set, because those small amounts of money, by the time you get older and you're ready to retire, those small amounts are going to make a huge difference. Okay. So I really can't stress the fact that being disciplined at a young age is tremendously helpful when you're older. It's just really hard to see that when you're young because you're so tempted to spend when you're younger. But yeah, that's get rich strategy number 2.